So good afternoon, welcome back. This afternoon we're going to work with exponents. So we're going to introduce that topic, revisit it a little bit, and get into what we call some rules of exponents. First though, just let me go back a little bit. Remember we had a problem like this, repeated addition. Like if I have 9 plus 9 plus 9 plus 9 plus 9. We learned that repeated addition, we're allowed to represent that using multiplication. So if I have 5 9s added together, I can write that as 5 times 9. So I can represent that using multiplication. So that also crossed over using like our variables. So if I have m plus m plus m plus m plus m, in other words, if I have 1, 2, 3, 4, 5 m's added together, I can write that as 5 times m, or most of the time you'll just see that as written as, we'll write that as just 5m. But remember, 5m represents 5 m's added together. So make sure we pick up on that. Multiplication is repeated addition. Now, when we get into exponents, we see things like this. So if I see 2 times 2 times 2 times 2 times 2, notice that's repeated multiplication. If I have repeated multiplication, that's when I'm allowed to use what we call exponents. So I can raise this to 2 to the 5th power. So this number here is referred to as an exponent, or we also sometimes use the word power. So I could read that as 2 to the 5th power. And again, the 2 in this case is called our base. That's what's being raised to this exponent or this power. So when I have m times m times m times m times m, notice again how this is represented as a repeated multiplication problem. And again, repeated multiplication, we can use this concept of exponents. So if I have 1, 2, 3, 4, 5 m's, I can represent that as m to the 5th power. And this is kind of our shortcut to repeated multiplication. So we can use what we call exponents to rewrite this. So let's put this into action a little bit. Let's look at some problems involving multiplication involving exponents. So notice how we have m to the 3rd times m to the 4th. Now, I understand that m to the 3rd just means m times m times m. And then we're going to multiply it by m to the 4th, which also means m times m times m times m. So what picking up on is this can translate into this meaning. But we also can pick up on, there is a simple way to write this. If we got 1, 2, 3, 4, 5, 6, 7 m's multiplied together, I can change that to m to the 7th power. So m to the 3rd times m to the 4th can be represented by m to the 7th. So what we pick up on is, as a shortcut, if I have m to the 3rd times m to the 4th, what we can do is keep the base the same and then just add those exponents, 3 plus 4, and we have m to the 7th. So if we have something raised to a power and we have the bases are the same, what we're allowed to do to simplify that is add those exponents together. That's what we're looking for. So one of our rules is if we have something raised to an exponent times the same thing raised to an exponent, in other words, if our bases are the same, to simplify that, all we have to do is add our exponents together, and that's going to put it in what we call simplest terms. So let's look at our next example. We have m to the 3rd raised to the 4th power. So remember, this 4 means there are 4 of these. So this kind of means m to the 3rd times m to the 3rd times m to the 3rd times m to the 3rd. Because again, that exponent represents repeated multiplication. What's being raised to the exponent is these m cubes, m to the 3rds. We also pick up on that, really all this means is m times 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 m. That's what that literally means. What we can pick up on is we have 3, 6, 9, 12. So that's the same thing as m to the 12th power. So what we pick up on is if we have a power raised to a power like this, our shortcut is we actually can multiply those exponents together to get that answer. So our shortcut says if I have m to the third raised to the fourth power, I can write this as m to the 3 times 4, which in other words, I would get m to the 12th power. That would be a way to simplify that expression. So let's look at this next example. We have m to the 5th divided by m cubed. So notice how we even drop that power off there. I didn't say m to the 5th power. I just said m to the 5th. So you'll start to pick up on some ways we say these things. So m to the 5th kind of means 5 m's multiplied together. M times m times m times m times m. And I'm dividing by m cubed. In other words, I've got 3 m's on the bottom. And we know in a division problem, if those factors are the same, we're allowed to cancel those out or divide those guys out. So I'm allowed to divide out those m's. And I'm left with m to the second power. So what we're picking up on is, if I have a division problem involving exponents, what we can do is actually subtract these exponents to get the answer. So my shortcut would be then, if I have m to the 5th divided by m to the 3rd, I can write that as m to the 5 minus 3, which would give me m squared. And that would be a way to do that problem. So we pick up on, there's a couple rules that we have here. If we're multiplying with the same bases, we are allowed to add the exponents to simplify. If I have a power raised to another power, we can simplify that by multiplying those exponents together. And if I'm dividing where the bases are the same, I'm allowed to simplify that by subtracting the exponents. So we have a to the m minus n. So those are 3 rules that we can take advantage of as shortcuts. If we don't understand those rules, we can always go back to translate it to what it literally means, and I can work it out that way. And sometimes that's what I have to do until I really understand something, is I break it down until I can see those patterns. Okay, let's see what else we can come up with. Stay tuned.